Okay. So we have a Truss Bridge. There are a number of bridges like these in Winnipeg, right? You go over Redwood, you go over the Louise Bridge, right? They are like this. So there's symmetry involved, right? Meaning the side lengths here would be the same. As you can tell, right? These markings, I will highlight the triangle I want you to focus on here, right? You have a triangle here, and you're told that these two angles are the same. Sorry, these side lengths are the same. So if this is 11.3 feet, this is also 11.3 feet, right? The markings are very important to us. Okay. We know that the height of this bridge, like the height of each truss, is 8 feet. And notice that the markings, I'm going to use a different color for that one. Notice these markings here. They're telling you that from here to here, it's like all these sections are going to be the same. Okay, so essentially, right, the same, the same, the same, same. So my game plan here is to find just one of these sections from here to here, and then I'll just multiply it by 1, 2, 3, 4, 5, 6. So I'll find that, this stretch from here to here, because I can see that it's at a right triangle, and then I'll figure that out there, okay? So I'll draw it out here. I know that's 11.3 feet, and this is 8 feet. This, I consider, you can consider this B for base, and that is a leg that you're missing. You have the hypotenuse, you're missing the leg, right? So leg is going to be square root of hypotenuse squared minus the other leg squared. B is going to be square root of the hypotenuse, which is 11.3 squared minus 8 squared. And that is, if you type in 11.3 squared minus 8 squared, I'm able to do that with my calculator. I don't know if you can, but I get 63.69. And that gives you 7.9806 if you round to 4 decimals. Why am I rounding to 4 decimals? Because the length of bridge is going to be 6 sections times the 7.9806. I'm not done yet, so I'm going to keep this. I'm going to double the decimals that I'm going to answer, that I'm going to have on my final answer. So I just go times 6. And that is 47.88, and we are in feet. The 1 tick is feet, okay? So length of bridge is 47.88 feet. There was a similar question like this on the provincial exam a couple of years ago. It wasn't exactly the same, but the same idea behind it. Calculate the interior angle of triangle ABC. And you need to be comfortable with this notation. Let's go find triangle ABC. So A is right here. A, B, C, right? So they want this triangle here that they're focusing on. This triangle ABC is right here. is it's fenced in by those 3 points. Okay, so we know that this is an isosceles, right? Because these two sides are the same, which is 11.3. I need to caution one thing here. So far, right, you have A, B, and C. We know that this is 11.3 feet, and this is 11.3 feet due to the markings. If there's one line across, all the sides are going to be the same length. But what is this? So far, I will say so far, this is an isosceles. Isosceles triangle. They want us to calculate the interior angles of this thing. Okay, so interior angles would be, these three are interior angles. What do we know about this length here? Because I want to try to use cosine law, by the way. That's what I'm going to do here. We know that this length here is a section plus another section, right? Because there's two sections here. So we'll just go 2 times b. 2 times 7.9806 is 1596. For that length. So that's triple S, use cosine law. That's why I do trig before I do this unit. Okay, so I'm going to find A first. That's my game plan. So cosine of A, not just A, right? Some of the tests that I was marking, you just put down A like that. It's cosine of A, okay? Would be, but this was done fairly well. You did subtract the side across, and that was done well. There's 11.3 squared plus 11.3 squared. And at the bottom, you have 2 times 11.3 times 11.3. Just happens to be like that. Let's come up with the top. That gives you 0.6584. And the denominator gives us 255.38. Okay, Brandon. Okay, Havana, I got you. We're on page 185 in our booklets. So top, bottom. So far we can say that this is equal to that, and this is equal to that. You can go one step further to say that this is 0.00257, and it keeps going. So this is okay to say equals. It's all equal to each other, but this is not okay. The next step, you have to start a new line. Angle A is going to be cosine inverse of that decimal. Some of you kept on going as equal to cosine inverse, like that's not right. Okay, this number you bring down, and then it's A only like this, cosine inverse, and that gives you 89.85 degrees. I'm sure they tried to make it 90, but hey, it is what it is. We go by this. So how could we find B and C? If these two are the same, then this angle is the same as that angle. And then we use the property of angle B is going to be 180 minus A minus the one I just found. All of that divided by 2, because these are the same. So angle B is 45.07 degrees, and angle C is also going to be 45.07 degrees because these two angles will be the same. It's an isosceles triangle. It's just flipped upside down. have that. So these are all the interior angles. You can box them all in. And this one here too, right? So these three would be considered the interior angles. And this formula comes straight from one of the pages where I gave you a bunch of notes, like the whole page was just notes on isosceles triangles, finding the two base angles, so to speak, or the ones that are across the equal sides. And we're going to take a little break here. Open AC1. I'm not going to make this an AC. It's just going to be a worksheet. If you're in class, you're going to get a paper copy. But go ahead and try that worksheet, and I'll have it up on the screen here if you want to get started. And I did take some of it from this book already, but open it. It's already posted as a PDF. Try to work through those questions. Would you be able to answer? Okay, Jarrell. Sorry, I just saw the question on the back side. Can you please go back to the booklet? I never did this part. I don't know why they don't have it on the previous page, but it says classify ABC and ABD by angle measure and side length, because that's what I'm going to ask you to do. Okay, how can you classify them by angle measure? Classify by angle and by side. Okay. Angle, you have three options. It's acute, right, and obtuse. And for side, you have equilateral, isosceles, and scalene. Scalene is when all sides are different. And I'm just going to ask you to go to the back side and just think of ABC again, and I'll just show you what that looks like. I know some of you are writing this down, so go for it, but I'm going to come back to it anyways. But ABC is the one we just worked with here. That's the one that they're interested in. And so let's just write that down one more time because it's important for you to understand. ABC like this. This is 11.3, 11.3, and this is 15.96 or something like that. So we know that these two are the same. We know that this one was 89.95 and that these ones were 45.05, 45.05 or something like that. Based on the angles, they are all less than 90. So triangle ABC is going to be acute and two sides are the same. So this is actually an isosceles, acute isosceles. That's what triangle ABC is. So you could have said isosceles acute, but I don't know. It doesn't really matter to me. But you have both there. Because every single one, this is technically not 90. If this had been 90, it would have been a right isosceles, but right now it's acute isosceles. And then triangle ABD, I will go to the back side and just highlight it. ABD is this one right here. It's a right triangle. You can tell that. Okay? Triangle ABD. I'll just make a diagram here. We know that's a 90. We know that this is 8 feet, right? That's the height of the bridge. We know that this is 6.09 or something like that feet, and we know that this is 11.3 feet. This is all from the bridge, right? It's all from the bridge, from the diagram. So we definitely know that this is a right triangle, and all three sides are the same, so it's a right scalene triangle, right? All sides are different. And this goes without saying, okay? This is why that's a right triangle. So that's what I mean by classifying. You got to be able to determine those things, okay? Okay, so take a moment and answer that worksheet. Sure. So Brandon and Jarrell and Havana. Okay. All right, I'm going to start going over it and see how you did, or even if you weren't able to do it, this is the time to write down um, some of these examples, right? Using the following, answer the questions below, right? What's the measure of angle M? And angle M is the top here. Isosceles, right? because of these markings. Right? You know that both sides are 13 feet. It tells us more than just that. It tells us that these two angles will be the same, right? So we essentially, if these two sides are the same, we know that, right, both of these angles will be the same also. So it's giving you more than just two sides. It's actually giving you two angles, right? So to find angle M, all we have to do is we have to take 180, right, and subtract 42, 42, right? Or 2 times 42, it's up to you. And that is 84, so that would be 96 degrees. And the reason why it's 2 marks is because you have to identify it's an isosceles. You have to figure out that because of that, you are given a second angle, and then do this calculation to figure out M. Okay. Classify MNP, so triangle MNP, by angle measure and by side length. So by angle measure, right, we have one that is obtuse, right? So this would be an obtuse isosceles triangle, okay? Because of this, greater than 90. Okay, and that's why this turns into an obtuse. And isosceles goes without saying, right? We're given that there. Okay. Classify each triangle by angle measure and side length. Give reasons for your classifications. Okay. So here we have two different angles. So we're going to figure out this angle right here. You can call this A if you'd like, capital A. So capital A would be 180 minus 52 minus 38. And that gives you a 90, right? So you know that this is 90, which we kind of suspected. So we know that this is a right triangle. When it comes to angles, you look at it, hey, there's a 90. It's a right triangle. And because all three angles are different, all three sides will be different too. So this is a scalene. I'll make a note here. And I don't know if I mentioned this in the videos, right? All angles different, therefore all sides are different. Sorry, there it is. If all angles are different, therefore all sides are different. And it goes vice versa. If you see that all sides are different in length, then you will figure out, and it's tied with the fact that the longest side will be across the largest angle, right? So if you have three different side lengths, it should go biggest, medium, small, right? And if they're all the same, like an equilateral, then you have 60, 60, 60, right? Next, this one right here, I'm telling you that the top here is 150, and I don't know if you see the markings, right? We know for sure this is an isosceles, for sure. And we have one bigger than 50. As soon as you have one bigger than 50, you can start saying obtuse isosceles, right? Because of that, we're done. Here we have one that measures 60, and that one I was hoping you were going to look at and you're like, wait a minute, what's happening there? Well, this is what's happening. This side, do this with me, you can say that this side is equal to that side just by looking at the numbers, right? These two sides, meaning the angles, well, first of all, this is going to be an isosceles for sure, if not equilateral. That means that this angle and the angle across from that other side, these are going to be the same. Let's go double line through it. Right? If these two sides are the same, then the angles across those two sides will measure the same. Okay? So let's call this B and C and this A, right? This is the original. B and C are here. Well, how would I find B or C? Well, they're the same. So angle B is going to be 180 minus the 60 divided in half, because right, you take away the 60, whatever is left is going to be split amongst these evenly. So that's 120 divided by 2, which is 60 degrees, which is also equal to angle C, right? Angle C and B, they're the same, they're 60. So now we know that this is 60 degrees, this is 60 degrees, and this is 60 degrees. This is actually an equilateral and specifically acute. Sorry, I usually do the angle first. Acute equilateral, even though there's no such thing as obtuse equilateral, right? Because it has to be 60. All of them have to be 60 for it to be equilateral in terms of a triangle. So if you just wrote this down, I would honor it, right? Equilateral. But to be in line with what we're doing, it's acute equilateral. Okay. Let's go to the back side. And here you're going to have to do some trig. And it's a good good idea, sorry, to review sine law here, because I noticed that for some of you, you were not quite sure how to set it up. You had the right idea, but it's somehow, and I don't know if, you know, if it was because it was done right way at the beginning, you kind of forgot about it. So here we go. Okay, so this is your second go at it. You look at this triangle, it's like, how can I do this? You have a pair. If you identify a pair, right, you know you can use sine law, okay? So this is a 90 here, so you start with your pair, sine of 90 degrees over 2.8 centimeters is equal to, and you have this angle which allows you to find the side across from it. So make sure your angles are at the top, and it's always sine, right? It's not just the angles, right? So you put the x there. And then it's cross multiply and divide. So you write down that x is going to be 2.8 multiplying with this. Order doesn't really matter there. And sine of 90 is equal to 1. So it's not going to change anything, but this is mathematically correct. Okay, so I'm going to go 2.8 times sine of 27 divided by sine of 90, just to show you nothing changes, right? It's divided by 1, so 1.27, and we are in centimeters. That's your answer there. Okay. Okay. We have this as being a pair right there. How do we find this side length? Well, we have these two angles, so we just need to find this third one. This is a hidden pair, like you have your pair, but you figure out this. This is going to be 180 minus 49 minus the 90 here, right? And so what are we at? 31? Yeah, 31 degrees. That's this angle right there. That's the one that we're going to need for this. So we go sine of 49 over 20.2 is equal to sine of not 90, because then you'd be finding this side, sine of 31 over x. Okay, and you cross multiply and divide there, so you go 20.2 times sine of 31 divided by sine of 49. And what is that equal to? Almost done, guys, almost done. Hang in there. Millimeters. Here, use Pythagorean theorem. Because you're given 2 out of 3 sides, use Pythagorean theorem. Use Pythagorean theorem. So this is C for me, or a hypotenuse, I should say. This is leg, and this is another leg. Hypotenuse always across the 90. So there's 2 legs and hypotenuse. So this would be x is equal to the hypotenuse squared minus the other leg squared. And that is 1883.84. Square root that, and that's 43.40, and we are in feet. I'll do the area quickly. What's the area of this? Well, you need area of a triangle is base times height divided by 2. That's the area of a triangle, right? I need the height. This is the height. So I'm going to figure it out. You know this is an isosceles, so that means that this line that goes from the top down splits this in half. So you know this is 25 and this is 25. So let's just cut out a right triangle out of this. Take this one out. This is 45. This is 25. We're going to figure out, this is A. We can call this lowercase a if you want. We're going to figure out what that is. This is also a leg, right? So A is going to be 45 squared minus 25 squared. And that's 1400. $37.4166. I'm going to keep it at 4 decimals because I'm still going to use it. This is the height of triangle, right? This here, that'd be the height of the triangle. So the area would be base. Watch out, folks. You got to go back to this. The base of the triangle you're working with is 50 times the height, which is 37.4166 divided by 2. And that's 935.41 square meters. Squared meters, okay? I'm not going to give you a whole lot here. I think all I would want you to do is try a couple of questions. We'll go page 187 to 188. And you have all spring break to do it. Okay, and then when we come back, I'll go over those after the break. We'll call this a day. Have a great spring break.